Hey there, we're going to look at 6.3a today on solving linear systems by elimination. This is the third of our three methods that we've been talking about in this unit. And so our objective today will be to solve systems using elimination, and this falls under our two standards in AREI 6, dealing with solving systems and dealing with them using linear combinations. And so let's look at what is the elimination method first. So the elimination method is another method used to solve systems of linear equations. Now, if you recall, we've dealt with three different methods in this unit. Method 1 was solving by graphing. Method 2 was solving by substitution. And method 3 is solving by elimination. Now, there are other methods to be able to solve by. We could solve by matrices, and we could solve by what's known as Cramer's rule, which is a method that you would learn if you take calculus. But the three that we are focusing on for this unit, for Algebra 1, is graphing, substitution, and elimination. And so what are the steps to be able to solve with elimination? Our first step is that we're going to either add or subtract the equations together to eliminate one of the variables, and then we'll be able to solve for the other variable. So let's say, for example, we want to eliminate the x. That means that we will then solve for the y. Step 2 is to substitute the value into either original equation to find the value of the eliminated variable. So in our example, we said that we eliminated x and solved for y, right? So we're going to now take that y value that we found and substitute it back to find the x. And then we will write our solution as an ordered pair. Because again, if these two lines intersect, then the solution is an ordered pair. And so we've got three examples that we're going to look at today. In example 1, we're going to solve by adding. And so let's look at that example now. And so we've got 2x plus 3y is equal to 21. That's our first line, our first equation. And our second equation is 5x minus 3y is equal to 0. And so the goal of elimination is to get one of the variables to eliminate. And so if we look at the y's, right, and what we're going to be doing is we want to have these lined up. We want to have the x's lined up, we want to have the y's lined up, and we want to have the constants lined up. The best way to do this is in standard form. You could have them both in slope-intercept form, but this is best in standard form. And so what we're going to see is if I add these two equations together, watch what happens. 2x plus 5x gives us 7x. Positive 3y plus negative 3y is equal to 0. So these two cancel. We come across the equal sign. 21 plus 0 is 21. Now if we go back to our steps, right? Step 1 said to add or subtract to be able to eliminate one of the variables. So we, in this case, eliminated the y, and we are now going to solve for the x. And so we're going to divide both sides by the 7, and x is equal to 3. And so in my order pair for the solution, I'm going to have 3 comma something, because the x was equal to 3. Now I'm going to take this piece of information and substitute back into one of the original equations. It could be the first or it could be the second. It doesn't matter which one we choose. What matters is finding the other variable. And so what we're going to get is 2 times the 3 plus 3y is equal to 21. Now, if you want to substitute in the second equation, you are more than welcome to, and you will get the same value for y in the end. 2 times 3 is 6. Plus 3y equals 21. We're going to subtract the 6 from both sides and get that 3y is equal to 15. And dividing both sides by the 3, we get that y is equal to 5. And so the point of intersection of these two equations will be at the order pair 3, 5. And that's it for doing elimination. We're going to add the equations together, Or what we're going to see in example 2, we're going to subtract the equations together to be able to eliminate one of the variables, solve for the other, and get this done. And so, in this problem, what do we have to do? The y's aren't going to cancel here. If I do negative y and then either add or subtract 3y, I don't get it to cancel. But look at the x's here. I got 4x and 4x. If I were to subtract those two equations from each other, the x's would cancel. Now, you can do straight subtraction and get everything to cancel, but you got to pay attention to your signs. And so that is why typically when we do subtraction, we're going to rewrite this as an addition problem. And here's how we're going to write it as addition. This negative will distribute to everything. And so we get negative 4x minus 3y is equal to negative 5. And now I'm going to add these equations together. 4x and negative 4x will cancel. Negative y plus negative 3y would be negative 4y. 9 minus 5, or 9 plus negative 5 is 4. We'll divide both sides by the negative 4. And we get y is equal to negative 1. And so my ordered pair, the y value is negative 1. We're going to take this, come back to one of the originals. I'm going to plug into the first equation here. And so I'm going to get 4x minus negative 1 is equal to 9. The double negative becomes positive. 4x plus 1 equals 9. Minus the 1 from both sides. And we get that 4x is equal to 8. And so dividing by 4, we get that x is equal to 2. And so my ordered pair, the point of intersection for these two equations is at 2, negative 1. All right, let's look at our last example here, example 3. Remember in section 2b, we talked about special systems. And with special systems, we're looking to see when the variables go away, is the statement true or false? Let's see what happens in this problem. So which way should I go to get something to eliminate here? Should I add or should I subtract? Well, look at the values. I've got a 3x and a 3x, right? So if I were to subtract 3x minus 3x, it would cancel. And so let's use subtraction here. So I've got 3x minus 3x. That part cancels. 8y minus 8y. Well, that's also 0, so this cancels. So everything on the left simplifies to 0. On the right, I've got 12 minus negative 2. So that's 12 plus 2, which is 14. Now, ask yourself, is 0 equal to 14? No. So this is no solution. Now, had we gotten that 0 is equal to 0 or 5 is equal to 5 or anything that would be a true statement, then my answer would be infinitely many solutions. That's the number of solutions, and the equation of the line would be the solution because all those points along that line would be solutions. And so that's it for this lesson. The word of the day is elimination. Again, the word of the day is elimination. And so with that being said, don't forget that if you haven't already, to go take that quiz on 6.2 and get that done. And that is it for today. Again, if you need me, the office hours today are 3 to 6 because I'm in the school packing up all of our stuff, all my stuff from this school year. So again, office hours 3 to 6 today if you need my assistance. Otherwise, y'all have a great day, and I will catch you tomorrow.